bigger and bigger on the moon.
Okay. And looks like we're in just a couple of minutes. We're going to take watch another video. This one by Juan Ruiz, talking about the surface of the moon.
My favorite.
Yes. Well, when you talk about surface, you're talking about geology.
Yeah.
And the topography, the geography. So there's so many things to talk about. And then after that, we're going to take a break. Just have an eclipse view until 4:20. And so Juan, just an outstanding educator, one of many outstanding educators here. And so we're going to be excited to hear from him. So let's take a couple more questions before then, and then we'll go to John's video, and then we'll take about 15 minutes and just do an eclipse view. So let's take one or two more questions. Let's see. How would the view be from the International Space Station?
So from the International Space Station, they would still see the eclipse, the lunar eclipse, just fine. Because the moon is a sphere, maybe a little. No, you won't. It'll look basically the same.
Yeah.
Probably a lot clearer.
And you see the astronauts, they've watched eclipses from the space station before and gotten pictures of it.
Mm-hmm.
You imagine, they're not that far up there, but it's a different view. You don't have the atmosphere to look through. You don't have to worry about clouds and that sort of thing.
Everyone thinks about the ice as just being way out there, but it's really close.
Yeah, it's not that far up there.
Really, really close. It's just whipping along.
Yeah. All right, well, let's play Juan's video about the surface of the moon, and then after that, we'll just go into a break until about 4:20, where we can just enjoy views of the moon.
Hi, how's everyone doing? My name is Juan Alberto Ruiz, and I'm an educator here at Lowell Observatory, and I'm going to talk to you about lunar features today. So the way we have observed the moon has changed drastically throughout human history. Whenever you look up and see a full moon with your naked eye, you can clearly see lighter and darker patches across the surface. Cultures from all across the globe have seen things across these contrasting surfaces, like a man or a face or even a bunny. But the lighter patches are what we refer to as the lunar highlands. This is where you tend to see the most craters. The crust is the thickest in these areas and tends to be older than the darker patches. The far side of the moon is covered with craters in the areas we also refer to as highlands. The biggest moon's craters can be found on the far side. It is known as the Aitken Basin with a diameter of 2,500 kilometers and a depth of 12 kilometers. The dark patches are known as the mare, and that is Latin for sea because at one point in human history, we actually thought the moon was filled with liquid water. We now know that mare are some flatter, smoother areas on the moon, and it's filled with a lot of basalt. Now, we think that this area on the moon is a lot thinner compared to the crust on the highlands. So we believe that these giant impacts from meteors and comets actually broke through the crust into the mantle, and all that molten rock, the magma, actually erupted towards the surface and completely filled the near side of the moon with magma, which eventually cooled off and left us this flat, darker areas that we refer to as the mare. These areas are younger than the highlands, and that is why we tend to see less craters.